combination of resistances in series. So we have two resistors. They are connected in series. Okay. And same current will pass. So which physical quantity remains the same? Current. Same current passes. If we say battery potential is V, then individual potential differences are V1 and V2. Okay, so that total potential is sum of these two. Using Ohm's formula, V is equal to IR, we'll write V1 as IR1, V2 as IR2, and total potential as total current into equivalent resistance in series combination. Take I common, cancel out on both sides. So this is the formula. And this is maximum possible value of resistance that we can have. Maximum possible value of resistance. Is that okay? So this is combination in series. Then combination in parallel. Still the students are joining and there are only 45 students. 47. Why they are coming late? बहुत बच्चे एब्सेंट हो रहे हैं. Okay, so in parallel, combination of resistances in parallel now. So let us join them in parallel. So that potential difference will remain the same. And current splits. Current gets divided into parts now in parallel. So in place of V equal to V1 plus V2, we will have I equal to I1 plus I2 here. Total current is the sum of two currents. Again using V is equal to IR, we can now write I is equal to V over R. So put I1 equal to V over R1, I2 V over R2, and total current, total potential over equivalent resistance in parallel combination. Why we are not writing V1, V2? Because potential is same in parallel, V is same. We can write like this. Take V common, V gets cancelled, so we are left with our result, this. 1 over Rp is 1 over R1 plus 1 over R2. This is minimum possible resistance we can have. Out of a combination of resistances, if we want to have maximum current or minimum resistance, that we should connect the resistances in parallel. So this will give us minimum possible resistance. Okay. So are both the cases clear? All right. So do one numerical now. Tell me the answer. Can you tell me how these resistors are connected in series or in parallel? If anybody knows, raise hand. Yes. R1, R2, R3 are in series or in parallel? Riddhi. Okay, Riddhi, unmute yourself.
Ma'am, in series. हम सीरीज में है।
In series, these are in parallel. अगर ये दोनों वायर्स नहीं होती तो सीरीज में होते, बट दीज वायर्स आर ऑल्सो देयर, सो दैट्स वाई दीज आर इन पैरेलल. ठीक है, तो ये शॉर्ट हो जाती हैं व्हेन देयर आर नंबर ऑफ कनेक्शंस. तो ये कुछ अलग कंसेप्ट हो जाता है, पोटेंशियल सेम हो जाता है. सपोज कर लो कि ए पॉइंट V1 पोटेंशियल पे, B point V2 पोटेंशियल पे, ऑब्वियसली दे आर डिफरेंट पोटेंशियल्स, दैट्स व्हाई करंट इज फ्लोइंग. ठीक है, तो ये जो पोटेंशियल है R1 पे V1 होगा. फ्रॉम हेयर ऑल्सो यू विल से हेयर V1, हेयर ऑल्सो V1. ये क्योंकि वायर है, यहाँ पे कनेक्शन है, तो ये सेम पोटेंशियल यहाँ पे होगा. अब B पॉइंट की वजह से हेयर पोटेंशियल इज V2 और सेम पोटेंशियल विल ट्रेवल हेयर एंड हेयर ऑल्सो. Now see the potential differences across the three resistors. इस R1 के अक्रॉस V1 V2, R2 के अक्रॉस V2 V1, ठीक है, R3 के अक्रॉस भी V1 V2 है. इसका मतलब तीनों रेजिस्टर्स का पोटेंशियल डिफरेंस सेम आ रहा है. तो पोटेंशियल सेम कौन से कॉम्बिनेशन में होता है? पैरेलल में. सो दैट्स व्हाई दीज थ्री रेजिस्टर्स आर इन पैरेलल. ठीक है, अगर आप इसका इक्विवेलेंट सिंपल डायग्राम बनाओगे then it will be clear to you. ये A पॉइंट है, ये B पॉइंट है, तो here V1 तीनों साइड्स पे V1 होगा बिकॉज ऑफ दिस. ठीक है, एंड इधर V2 पोटेंशियल है, तो यहाँ V2 होगा तीनों पे. So again they are having same potential differences. So these are in parallel. तो वो भी यही था, ये भी यही था. So that's why these three resistances are in parallel, not in series. ठीक है, let us do a derivation of Jowls law of heating now. First of all, the statement: when current passes through a conductor for some time or a wire for some time, it gets heated up and amount of heat produced is given by this I square RT. Okay, there are two more forms, but we will prove this first by definition of potential difference. Potential is work done per unit charge. So when current flows, then charge is transferred from one place to another place. So some work is done. So we are going to find that work. W is QV. This is equation number 1. Now put V is equal to IR from Ohm's law. Using Ohm's law, we have V is equal to IR, and by definition of current, I is equal to Q by T. So we will put Q equal to IT. Make both the substitutions in equation number 1. So what do we get? IT into IR. I square RT later on this work done is stored in the form of heat. It is dissipated in the form of heat. So that's why this is heat produced. Whatever work is done, ultimately it is converted into heat. Still students are entering. Yuvraj just entered. Tarun is also entering. So have a look at the derivation once. Vaibhav Aneja is coming now. Yes, have a look. If you have any doubts, you can tell me. All right. Now who will tell me the applications of Jowls law of heating? Raise hand. Four applications we did. We did 4 applications. Fuse, filament of bulb, heating element of nichrome, and connecting wires made of copper. Okay. Now, how is Jowls law of heating applicable in case of a fuse wire? Who will? Who will tell? Raise hand. ये तो आता ही होगा, बोलो. Fuse wire is made up of tin lead alloy. Fuse wire has 2 characteristics. What are those characteristics? Low melting point and high resistivity. Low melting point and high resistivity. Now who will explain how fuse saves the delicate electrical appliances from damage during voltage fluctuations? Yes. Who will explain this? Only 2-3 students are always there. Riddhi, Samriddhi is there, and Diya is there. What about others? Okay, then I'll ask. Assis, आप बताइए. Assis, turn on your video and you tell me.
Yes, ma'am.
Yes, fuse का बताइए. बच्चे फ्यूज का असीस
मैम क्वेश्चन क्या है?
कि फ्यूज का कैसे फंक्शन क्या है फ्यूज का.
मैम वो जब हाई वोल्टेज होती है तो आगे अप्लायंसेस डैमेज ना हो, इसलिए वो लगाया जाता है ताकि वो सर्किट ब्रेक कर दे.
हाँ, कैसे? हाउ इट ब्रेक्स द सर्किट?
मैम वो मेल्ट हो जाता है.
कैसे?
मैम जब हाई वोल्टेज आता है तो अगर फ्यूज वो मतलब करंट आगे नहीं पास करता जब ज्यादा हो जाता है तो, और वो मेल्ट हो जाता है.
ओके, कुछ कुछ ठीक है. तो इसको कैसे एक्सप्लेन करोगे? विद 2 कैरेक्टरिस्टिक्स. ठीक है. तो यू विल टेल कि ड्यूरिंग वोल्टेज फ्लक्चुएशन व्हेन लार्ज अमाउंट ऑफ करंट passes due to Joule's law of heating, large amount of heat is produced, and because of low melting point the fuse wire melts easily. So because of both these things, fuse blows off, making the circuit incomplete temporarily. ठीक है, जब करंट थोड़ा सा भी सेफ लिमिट से एक्सीड करेगा, then more heat will be produced than normal, and because of that more heat and low melting point of fuse wire, it will melt very easily, and it will make the circuit incomplete temporarily, and appliances will be saved from damage. So फिर से वो फ्यूज को रिप्लेस कर देते हैं, तो फिर से वो फंक्शन करने लग जाते हैं, बट विदाउट एनी डैमेज. Okay, so this was fuse. Second application, filament of bulb is made up of tungsten, because tungsten has two characteristics: high resistance or resistivity and high melting point. तो high melting point का advantage ये है कि it doesn't melt, filament doesn't melt even when it becomes red hot or white hot. और हाई मेल्टिंग हाई रेजिस्टेंस से क्या एडवांटेज होगा? अकॉर्डिंग टू जॉल्स लॉ ऑफ हीट, मोर हीट विल बी प्रोड्यूस्ड बिकॉज H इज डायरेक्टली प्रोपोर्शनल टू R. सो मोर हीट विल बी प्रोड्यूस्ड और मोर एनर्जी विल बी प्रोड्यूस्ड इन द फॉर्म ऑफ हीट एंड लाइट. तो ज्यादा लाइट इट विल गिव आउट, तो वो बल्ब जो है वो ज्यादा लाइट देगा. थर्ड है, हीटिंग एलिमेंट इज मेड अप ऑफ नाइक्रोम. So I told you 3 points, 3 characteristics. Yes, raise hand. Who will tell me 3 characteristics? मैं पूछूं फिर? All this you have done. This chapter you have prepared for first PT also. Harminder, you tell me. Yes, Harminder. Video on करके बोलो. Harminder, unmute yourself. Girls का 1 मिनट में हो जाता है.
Yes, ma'am.
ठाकुर अभी करके दिखाएगी. हाँ हरमिंदर, you are unmuted. You can speak. Turn your video on.
Question repeat करना.
Yes हरमिंदर.
मैम क्वेश्चन रिपीट करना.
क्वेश्चन यही है, हीटिंग एलिमेंट.
पता नहीं.
देखो 3 पॉइंट्स हैं, आप लेट आते हो हर बार, फिर बीच में चले भी जाते हो समटाइम्स. ओके ईशा, आप बताइए. ईशा.
High resistance. It is made up of alloy
Nichrome.
and
Nichrome is an alloy.
and its melting point is less.
ये तो नहीं मैंने बताया. ओके, तो आई टेल यू 3 पॉइंट्स बताए थे. फर्स्ट था बिकॉज ऑफ हाई रेजिस्टिविटी और रेजिस्टेंस, लार्ज अमाउंट ऑफ हीट इज प्रोड्यूस्ड अकॉर्डिंग टू जॉल्स लॉ ऑफ हीटिंग, जो चाहिए. सेकंड है, इट डजंट गेट ऑक्सीडाइज्ड इवन एट extremely high temperature, it remains stable at extremely high temperatures. थर्ड पॉइंट क्या था? वो उससे रिलेटेड नहीं था, मेल्टिंग पॉइंट से रिलेटेड. वो था कि since it is an alloy, its resistance doesn't change with temperature. So these are 3 characteristics of nichrome alloy, because of which it is used as heating element in devices like electric heater, geyser, toaster, iron, etc. Fourth application is connecting wires. They are made up of a good conductor like copper. What is the reason? Again, you can say it is a good conductor, so its resistance is very small. Because of small resistance, H is also small. Heat is directly proportional to resistance. So because of small heat produced, okay, we won't get injured, because we always or we often come in contact with connecting wires. So this is the reason. Okay. Now another question is how are different appliances in a room connected or in a house connected, in series or in parallel, and why? Yes, who will tell me? How are electrical appliances in a house connected? Who will tell? Yes. Anybody raise hand? Yes, हर्षिका आप बोलो.
मैम इन पैरेलल
Yes.
बिकॉज अगर एक अगर अपनी डैमेज हो जाता है तो बाकी वो चलते रहेंगे.
Why? Why?
मैम बिकॉज पैरेलल कॉम्बिनेशन में जो पोटेंशियल डिफरेंस है वो सेम होता है पर इसलिए वो जब डैमेज हो जाएगा तो बाकी चलते रहेंगे.
Yes. Very good. This is correct. So they are connected in parallel. They will get same voltage, same potential difference of 220 volt that is necessary for their operation. But since different current flows through different devices, so if one stops working, others will not. Whereas if they are connected in series, if one stops working, others will also stop working because they are connected one after the other. Same current passes through them. So they can't be in series. Okay, next question, write down one conceptual question. A student boils the water in an electric kettle. A student boils the water in an electric kettle for 20 minutes after being switched on. 20 मिनट के बाद एक केटल में वाटर बॉयल होता है नॉर्मली. यूजिंग द सेम मेन सप्लाई he wants to reduce the boiling time of water. He wants to reduce the boiling time of water. To do so, should he increase or decrease? To do so, should he increase or decrease the length of the heating element? And justify your answer. तो उसको क्या करना चाहिए अगर वो चाहता है कि कम टाइम में वाटर बॉयल हो जाए, तो उसको हीटिंग एलिमेंट की लेंथ इंक्रीज करनी चाहिए कि डिक्रीज करनी चाहिए? ठीक है. सो टू रिड्यूस द बॉइलिंग पॉइंट ऑफ वाटर यूजिंग सेम मेन सप्लाई, उसको उसकी पावर इंक्रीज करनी पड़ेगी. ठीक है. नाउ पी अगर आपकी पावर सप्लाई सेम है, पोटेंशियल सेम है, देन विच फॉर्मूला वी विल यूज? एक तो उसका अपना कुछ रेजिस्टेंस है केटल का. ठीक है. V सेम है, रेजिस्टेंस उसका कुछ होगा, तो विच फॉर्मूला ऑफ पावर वी विल यूज इन टर्म्स ऑफ दीज टू वेरिएबल्स? P is equal to V square upon R. So to increase the power, he must decrease the resistance. And since resistance is rho L by A, resistance is directly proportional to length. So he should, what he should do? Decrease the length of heating element. By this, the resistance will decrease, power will increase. So then water will be boiling in less time. So the answer is length of heating element should be decreased. Okay. Now what is open and closed circuit? कौन बताएगा? Open circuit and closed circuit. Who will tell me open circuit and closed circuit now? Open circuit means off. Closed circuit means on, through which current is flowing, in which bulb is glowing. And open circuit which is off, bulb is not glowing. So I can draw like this. Open circuit, closed circuit. In this case, bulb is not glowing. ये सर्कल जो होता है ये बल्ब का सिंबल ही है, ठीक है. आपकी कॉपीज में मैंने करेक्ट किया है. दैट इज नॉट द सर्कल आई एम पुटिंग, दिस इज अ पार्ट ऑफ द सिंबल. सो की इज ओपन, ऑफ, no current will flow through the bulb, it will not glow. This is closed circuit, current is flowing, so bulb is glowing. See this? Any doubt in the different types of circuits? Two different types of circuits, is that clear? Any doubt, you can still let me know. Okay, write one question now. Calculate the resistance of 1 kilometer long. Calculate the resistance of 1 kilometer long copper wire of radius 1 mm. 1 kilometer long copper wire of radius 1 millimeter. Note down resistivity of copper is 1.72 into 10 raised to power minus 8 ohm meter. 1.72 into 10 raised to power minus 8 ohm meter. Yes. So let's note down the data. The formula used will be R is equal to rho L by A. R is equal to rho L by A. So put in the values and solve, find resistance. ठीक है. Length of wire is, resistivity is 1.72 into 10 raised to power minus 8 ohm meter. That is in proper unit. We need not do anything. Then length of the wire is 1 kilometer. उसको करना पड़ेगा 1000 meter. Okay. And radius is 1 millimeter. So you will use formula pi r square for the area. Pi r. Radius is 1 millimeter means 10 raised power minus 3 meter. Pi r square. So solve this and tell me the answer in proper unit. Obviously resistance ohm में होगा, but solve and tell me what will be the answer. Yes, बताइए. Raise hand after solving. हरमिंदर को क्या हो गया है? ये लेट आया है ना? One Harminder is already there. This is another Harminder. Very bad. Yes, anybody with the answer? Anyone? That is 5.47 ohm. So tally your answer. It should be 5.